Hi guys, I'm back. So as you may have known, in the last video we programmed a streamlined collision detection system. But the problem is that it is kind of unrealistic in that when in collision, the object is just transformed with the minimum translation vector, while in reality, each of the two objects may bounce a little bit. So today we will fix that. So the intuition leading to the solution in this video is to calculate the force of impact between two objects based on their mass and velocity, and then just add the force to each of the object, which is in accordance with Newton's third law. To be more specific, today's video will revolve around the implementation of the work kinetic energy theorem.
Wow!
So the first thing to do is to set up the attributes necessary, which are specifically the weight of the object and the softness. These are functions that allow users to set up their own physics attributes. And then is a function that applies all the forces acting on the object. Then the next step is to implement the physics function into the default update function in each instance. And then there is just one final step before we can start calculating the impact force, which is getting the speed or velocity of the object, which is imperative in our equation. Basically, the dot product between two vectors is equal to the product of their length multiplied by cos theta. So we can determine cos theta by dividing the dot product by the product of their length. And then with the given values, we can now calculate the force of the impact using the formula shown above. After the force of impact is calculated, the force is now added to both of the objects. Now let's try running it. Okay, what the hell is happening? Okay, stop here. Apparently the force was too high. But now with a reasonable force, occasionally objects still stick with each other. I attribute this problem to the fact that one object may be involved in two separating axis tests, both of which returns true. As a result, each time the object is translated in a different direction, which cancels each other out. And a solution I've conceived for this is that when the object is translated, like a small distance can be added so that the next test it will not return true. Well, as you can see, it works now, although refinement is needed.
One eternity later.
It seems better this time, although it might still look unrealistic when we apply other forces from the environment such as friction or drag. It will look certainly better. So yeah, I think I'll call it a day for now.